Hi, in this video, I will walk through a complete confidence interval problem in an intro stats class. I will use an example of confidence interval of a proportion, even though a confidence interval problem for other parameters will work similarly. I assume you already know the basics about inferential statistics and confidence interval. Let's take this example. The EPA considers indoor radon level above 4 picocurie per liter, that's PCI per liter, of air to be high enough to require remedial measures. Tests in a random sample of 500 homes in Central County found 316 homes with indoor radon levels above 4 PCI per liter. Compute the 95% confidence interval for the population proportion of homes in Central County with radon level that exceeds EPA guidelines. Let's understand what's going on here. Read the problem carefully. Read several times if you have to. The first sentence is about the EPA standard. Does the problem ask us to do anything with it? After reading the problem several times, I found out that no, the problem isn't asking us to do anything with it. It's only there to link this and this and this. Radon level above 4 PCI per liter means the same thing as exceeds EPA guidelines. Second sentence. Note that it uses the word tests. But again, I read it carefully and I found out that the problem is not asking for a hypothesis test. The question is only telling the story that someone walked around 500 homes and checked them out using some sort of testing device, maybe a radon detector of some sort. So it says tests, but I'm not tricked into thinking that I need to do a hypothesis testing question. Lesson number 1, don't rush when reading. You'll get tripped up by words that look like a keyword, but isn't. All right, what else is going on in the second sentence? It gives us sample data. We're talking about observed data from the sample. The sample size is 500, and 316 of them satisfy a certain condition, namely to exceed EPA guidelines. That should remind you of binomial. Things that are success and failure, yes or no on something. Yes, exceed EPA guidelines, or no, doesn't exceed EPA guidelines. In an inferential statistics questions, things that feel binomial are questions about proportions. In fact, that's what it says in the third sentence, which is a question prompt. It says to compute the 95% confidence interval for the population proportion of homes in Central County that don't meet EPA guidelines. That's how you should spend time reading the question, understanding it, and getting from it, 1, the information given, and 2, what it's asking for. See how I already figured out kind of what it's going to be asking for even before getting to the question prompt. Just because I paid attention, I realized that this feels binomial, and in an inferential statistics question, things that feel binomial tend to be proportion questions. Let's write down how we structure our approach. Step 0, read carefully. What information is given? What is the question asking for? And that's what we just did. Let's now move on to step 1. Restate the question. restate what information is given and what the question is asking for, using the correct notation, distinguishing between sample and population. And while we're on this subject, let's do a quick summary. Proportion, P hat for sample, P for population. Mean, X bar for sample, mu for population. Standard deviation, S for sample, sigma for population. Variance, S squared for sample, sigma squared for population. For confidence interval, proportion uses the Z distribution, the standard normal distribution. The mean uses T or student's T distribution, and standard deviation and variance uses the chi-square distribution. For this problem, let's restate the information. We're given that the sample size is 500. The success, we're looking for homes that exceed EPA guidelines. And the number of successes is 316. That gets us a sample proportion, P hat, of 316 divided by 500. And that's equal to 0.632. That's the information given. Now, what is the question asking for? Asking for confidence interval of population proportion. So that's P at 95% confidence. Note that this question specifically says population proportion. Sometimes the question doesn't say the word population proportion. It may say something similar like true proportion, or it may just say proportion. It's up to us or you to understand that in inferential statistics, confidence interval and hypothesis testing always ask about the population parameter. So always use the population notation for the confidence interval and the hypotheses. As an aside here, in AP stats, use the student are always expected to say population or true proportion. That comes at the verbal conclusion. We'll get to that in a few minutes. So that's the restate step. Step 2, list and check conditions. Inferential statistics always comes with conditions. Confidence intervals and hypothesis tests in an introductory class are based on the rules of approximation and the central limit theorem. Those rules of approximation and the central limit theorem have requirements. If they're not met, you can't do confidence interval and hypothesis tests. Now, some teachers may not require checking conditions, but most do, and those that do, such as me, the part of checking condition carry a lot of point value on a question. Therefore, in this step, you need to know what the conditions are. For a proportion, here are the conditions. Number 1, the sample's observations are independent. The most common way to achieve independence is to be from an SRS, a simple random sample, that is roughly equivalent to sampling with replacement. So this usually breaks into SRS, and Right, the sample in this case is without replacement. We have 500 homes, and once we've checked the home, we don't check it in anymore. So we don't put it back in the pool of homes to check. So it is sampling without replacement. Under what circumstances can we sort of treat it like a sampling with replacement? The rule of thumb is if the sample size is no more than 10% of the population size. As an aside here, this is a purely rule of thumb for an introductory class. In general, we prefer big samples. The bigger, the better. When we have a sample size that's so big we cannot have independence, we will gladly take the big sample and do extra math to take care of the fact that the observations are not independent. But in an introductory class, we need to assume that the observations are independent, and that's why this condition is here. And number two is a so-called success failure condition. The idea of a success failure condition is that we don't want one side, either side, to overwhelm the other side, either the success side overwhelming the failure side or the failure side overwhelming the success side. So we want at least 10 successes and 10 failures each. There are books that sort of combine them together and write the success failure condition as NP times 1 minus P is greater than or equal to 10. That's perfectly fine too. I'll stick with this version because it's kind of easy. How do we compute successes and failures? Sometimes it's given in the question. For example, in this question, are we given success and failure? Yes, we are. But if not, then we take the sample size multiplied by the probability of success. That will get us the number of successes. So this is equivalent to saying that NP is greater than or equal to 10. And 10 failures, number of failures is sample size times the probability of failure, which is 1 minus P, the complement of success, right? So N times 1 minus P is greater than or equal to 10. Or the number of successes and failures are already given. So in this problem, what happens? Do we have SRS? Well, the word random is in the question. It doesn't say simple random, but for purposes of almost all inferential statistics question, if the word random shows up, we'll take it. We'll take it to mean that it was a simple random sample. Do we have a sample size that's less than or equal to 10% with population size? We'll say probably, and almost all teachers and exams will accept this, that a county, a whole county, probably has more than 5,000 homes. So 500 is less than or equal to 10% of 5,000. And the third condition is success failure. Yes, in this case, we don't need to compute them, we're given them. There are 316 successes. And the rest of them are failures, so 500 minus 316. And they're both greater than or equal to 10. All right, I want you to look at this and see that this is how you need to lay out the checking of the conditions. You need to list them, SRS, N is less than 10% of capital N, and success failure. You list them out and you write down all the checking. Let's take the second condition here. If I stop there, some teachers and professors may consider it to be incomplete because you're supposed to check that the number 500 is less than 10% of the population. And if you stop right here, you never did the checking. You have to have the statement that shows that the 500, which is the sample size, is less than or equal to 10% of the population size, which you assume to be more than 5,000. Same thing here. I found the two numbers, 316 and 184. I cannot just stop there. Many teachers and professors would consider it incomplete. I have to finish my sentence. I have to say that, yes, they are greater than or equal to 10. Even though it's kind of obvious, many teachers and professors will require it. And all conditions are met. Guess what? I have to actually say that. Say the words. Step 3 is to actually do the calculation. You can do this calculation using a graphing calculator, such as the Casio FX9750GII or the TI-84 or StatCrunch. I will now use StatCrunch. In StatCrunch, the way to do a confidence interval is under stats and look for the kind of statistics that we're going to work with. We're going to do proportions, so it will be under proportion stats. It branches into one sample versus two samples. In our case, it is one sample. We have one sample of 500. And over here is the choice is either with data or with summary. Data is when you have a whole list of all 500 homes in a list. You have a sample size of n and you have the list of all n. That's the only time when you click on with data. Otherwise, it's with summary. In this case, I don't have the list of all 500 homes. I have a summary that says the total is 500 and the total number of success is 316. So that's summary. So I click on with summary. Number of successes, 316. Number of observations, 500. That's the same as the sample size. And I'm not doing a hypothesis test. I'm doing a confidence interval for P, for population proportion. And the level is 0.95, 95%. And everything else I can just leave as default. Sometimes I want to see a few things. For example, let's say that if the question also happens to ask for critical values, then I'll check this so I can answer that question. But usually I just leave everything as default. I just need to enter number of successes and number of observations. And I click compute. This is the answer I receive. Here's the critical Z values that usually comes with a 95% confidence interval is 1.959964. Most people would just treat it as 1.96 as a nicely rounded number. And here are my lower limits and my upper limits. My lower limits is 0.5897, so it's 0.590. And my upper limit is 0.6742, so 0.674. Double check my data. The success count is 316 out of a total of 500. The parameter is P for proportion, and the sample proportion I calculated earlier is 0.632, and it's showing on StatCrunch also as 0.632. So I'm confident in these numbers. I go back to my paper and I write it down, lower limit, 0.590. Upper limit, 0.674. And that would be my confidence interval. Finally, I get to step 4, is for the verbal conclusion in context. This is super important. Statistics is an applied science where someone pays you money to answer a question. The time from when they ask you to when you answer them is usually several weeks or months apart. By that time, you need to give them a full verbal answer in context, or else they'd have no idea what you're talking about. I have a separate video on how to write a verbal conclusion in context. Check it out at the link above. Here's a good template for writing the verbal conclusion in context for a confidence interval. We are blank % confident. That the population blank, where you fill in the blank with the parameter of blank, where you fill in this blank with the context. Is between blank and blank, where these two blanks are the lower the upper limits. See how much verbal stuff goes into the conclusion? You computed the two numbers and they go here and there, but the rest of your answer is all words. So be careful with that. There's a lot of words in a stats class. So for this problem, how would I fill in this template? The percent confident is 95. We are 95% confident that the population, and the parameter here is proportion of. Now fill in the context. You can get the context from the question itself. Homes in Central County, and just get it straight out of the question. With radon level that exceed EPA guidelines is between, and here you fill in the numbers, 0.590 and 0.674. Let me tell you how a lot of teachers and professors would be grading on the verbal conclusion in context, and that includes me. First of all, we're looking for a measure of uncertainty. Inferential statistics can never be exact. The answer will be uncertain, but how uncertain the answer is actually an exact number. In this case, the 95% confidence level. If you state your answer in a way that is certain, that's like, I know for sure that the numbers are between 590 and 0.674, you will lose points, because in an inferential statistics conclusion can never be that sure. So I need to see the measure of uncertainty. We'd also want to see the context for the numbers. What are these numbers about? It's about homes with high radon level. Most people would be okay with any context that makes sense. But it's simplest. It's just simplest to just copy verbatim from the question prompt and you're good. And we're also looking for the word population proportion for the parameter. And in order for it to be a parameter, it has the word population in it. So what kind of measure is proportion? But is it a sample proportion or a population proportion? It's a population proportion. So we'd like to see the word population in it. And then finally, of course, we need to see the correct numbers. Sometimes a question asks you to give your answer in the form of point estimate plus or minus a margin of error. I have a video showing you how to do that. Check it out above. In this case, it's 0.632 plus or minus 0.042. Here's a summary of all the steps. Step 0 is to prepare. Step 1 is to restate the question, both the information given and what the question is asking for, using the correct sample versus population notation. The purpose of this step is to set your mind on the kind of problem you're working on. Once you've done this step, your brain is adjusted to know that you're going to be working on confidence interval of a proportion and not some other things. Step 2, conditions. Always do that. Step 3, compute. And step 4, make sure you conclude in context. All right, I hope that helps. Any questions, ask in the comments section. Like, share, and subscribe for more contents. And thanks for watching. Bye.